Okay, so this demo is just going to be a complete start to finish presentation of SOLIDWORKS schematics. This is actually all functionality we can do inside um, SOLIDWORKS Electrical Schematic Standard. So we don't have to go to 3D to do a panel layout. We're not going to use advanced PLCs or harnesses or anything. Just doing functionality that most of our customers need. And obviously, if you need to show more advanced functionality, by all means, adapt as you need to. But the point of this is to be a really easy and first look at the product. If you just burn through it at top speed, maybe you're done with it in 20 minutes or less. Um, if you take your time to really explain things, probably take about 45 minutes or so with PowerPoints and all that. So look at the system. I like to open it up just to show the different documents, and then immediately flip over to the components tab so we can kind of keep track on what's going where in the system. So as we start drawing, we'll go into the schematics tab and pick the wires, and be sure you're picking this 16 gauge wire style. You probably have a bunch of these L1, L2, kind of three-phase styles. Just be sure you pick the one that's came with the project. And really the main reason for that is we're just trying to make sure more stuff fills in. And when you show a from to report or whatever, you have the wire gauge come in, it just shows a little extra value, extra added information that got done for you. And then instead of going back up to wire draw symbol, Control R to repeat the command. Again, we're trying to minimize mouse travel on something like this, and maybe just kind of mess around a little bit, show the inverting and bending of the wires. Shows we're not just working with standard line tools. And now we're ready to start adding some symbols. So let's motor. If you've got two duplicate motors, because you got one maybe with the library, use the +1 version. It's one that's going to be modified from your default system library, and maybe kind of hover over some of these other wires to show how it just wants to really attach. And I always make a point of putting it right on top of these wires to make it look sloppy at first, but as soon as I click the button, the wires get trimmed away. That's a big ooh-ah moment for folks who use AutoCAD LT and DraftSight and tools like that to do their electrical designs. So it's amazing the little things that save people time are very impressive to them. Anyways, let's add the disconnector. We'll drag and drop that. Again, just show how it flips to grab right onto the wires. And I want to be sure I'm using the right version. Again, the +1 version if you have multiple ones showing up in that palette. And then we'll do the 3-pole. Add our circuit breaker and add our contactor. And then we'll describe, okay, the motor's not going to be inside the main electrical enclosure. We want it out on the conveyor. So draw the location box, conveyors, change location, and then we'll draw a terminal strip. Be sure that you're using the disconnectable terminal that is in the standard demo library. And of course, when you're doing this, asks you for that little arrow. People always get confused by that, or not always, but some people do when they're new to the product. Think of the arrow as going from inside the cabinet to outside the cabinet in this case. So I'm going to point towards leaving the cabinet. It's an exit arrow, so we're leaving the cabinet towards the right. And we hit OK. And now let's assign some components. So we'll start down here at the motor. And the way we've seen this done a lot is people would right click and go into symbol properties, then you have to click on a tab, then you have to click on a search button, and you're finally at this page. And that's a lot. It's 3 dialog boxes on the screen when you just don't need that. We can go instead say component, assign component. So we're showing that it's just a right click away to get exactly where you want to go and pick the motor we want. Same thing here, component, assign component. I've already set my manufacturer to SWST. If I had that cleared, you'd see a list of all my fuses, but I only have now the ones showing from the demo set. So it's just kind of moving through this. Makes it a little quicker to find everything you need. And component, assign part. Okay, here we just need to make one change because we're not seeing anything in the library. because I don't have any parts that are just power contacts. So we're going to come up here to contact to relays, say select. And so we're just moved up to the higher level class. Again, it was down here on the subclass of power. We just need to move up to the parent class of contactor relays, relays, and we'll see exactly what we need. And that's pretty good. We're ready to go. At this point, we're going to do just a quick error check. And to do that, we'll go to the project menu, go to design rule checks, and we'll see that we have 4 components. All the terminals from X1 have not been assigned to manufacturer parts, and none of the wires I've drawn actually have marks on them. So fix the marks first, number new wires, hit OK, and we're done. And next would be to assign the components to this terminal strip, but rather than doing these one at a time and saying, component, assign component, we'll just edit the terminal strip. And here I can assign, we'll pick the large terminal and associate cable cores. We're going to add a cable, and to find the cable really quickly, switch to AWG and then switch to power. And now you have 2 choices. You have your 14 gauge and 10 gauge. We'll use the 14 gauge initially and say OK. And what we'd like to do is just assign the cores to this. And we want to make sure that our green, yellow neutral wire, protection wire is on the bottom. And then we want to make sure that our terminal 4 right here, X1-4, make sure that that's on the bottom as well. That way we know the cores are all lined up right, so when we assign, it's going in correctly. And finally, we'll just make a quick drawing of this. Hit OK. And then we can show the drawing that we just created out of a button click. So terminal drawing looks great. And now we're ready to create the control circuit for this. So to create the control circuit, we'll jump into the macros. I'll show you the power supply getting dropped in, hit finish. I need to explain that other stuff in there. Number new wires. Now we've got, as you can see, it's a different wire style for our control, so it gets a different numbering. And then we'll go over to the control circuit, and we're going to start drawing a little ladder out. So we'll just draw a single wire. Make sure you're picking the one that says 18 gauge 24 volts DC. Again, from your symbol palette group. So there's a lot of these control wires. A lot of them look the same. Be sure you're in the one that says 18 gauge because this is the one that has the numbering set up right. Only need 1 wire. And I like to go from this little mark right below the 1 down to the 5. And then come out maybe a little more than halfway across the page. And we'll just drag this wire down a little bit, and as you can see, connection dots show up. And at this point, we'll expose our component list because we're going to need this contactor. Come over here to the symbols list and go to our command palette. We need a way to turn the motor on. Put that there. We need a way to turn the motor off. Let's zoom in a little bit. Put in a stop switch. And then we'll need our relay coil to actually charge up to close our contacts. And if we look at this component here, let's actually I'll just say insert symbol. We're going to add the relay coil symbol from that component, drop it right in place there. And we're also going to insert the remaining available circuit, which is the normally open contact. And we'll just drop that right down here below the switch. And we want our switch here to be illuminated, so we'll drag a light bulb indicator directly underneath the relay coil. And we will now assign some components. Actually, let's finish the wiring. So all I need to do is drag this 1 wire up and breaks it into those 3 segments that I need. If I grab this left segment here, start dragging, hit the control key, makes a copy, drag, hit the control key, and then drop. And then we'll do that 1 more time. Okay. And now I can just pick the two segments that I don't need and get rid of those. So, and finally, wire style. We're going to replace the wires on this side of the circuit, the ground side, through that equipotential with our ground style. Okay. And let's number our wires. So we can see our different wire numbers. And then finally, we'll assign some components here. And actually, let's look at a couple things before we do that. Just want to drag this cross-reference table over. We can see that it's telling us where our power contacts are. They're on page 2. That's our power page, row 5. And on page 3, row 4, that's where you're going to find the contactor, the normally open contact. So cross-reference table is dynamic and always stays up to date. Next step here, like I said, was to assign some components. So component, we're going to assign a manufacturer part. Let's add this e-stop. And here we're going to assign a part. And let's pick this one here to be sure that it highlights both circuits here. So you may have 2 of these. If you notice, this one only indicates 1 terminal because I've got 2 terminals on this particular part. This part's set up with 2 circuits with 2 terminals each, so this one actually fully satisfies my normally open button. Use that one and hit select, and you see it's got an available circuit now for a lamp. So what I can do is just tell it these 2 components are the same. Pick S1, hit OK, and now S1 includes a light, and its terminals are all labeled, so we're ready to go. Next step, we're going to do some, we're going to add some motors. This gets us, oh wait, yeah, I forgot one step. We're going to create our origin destination arrows. We want to go from power there to ground here. We get these little blue indicators. And I'm going to pick the control page to solve these, so that way you'll actually see the wires change. So I say solve equipotential conflicts. We'll use wire number 204 there. And solve equipotential conflicts. Use ground 1. So those all updated. And then we'll just double click to go to the power page, show that link. And what we'd like to do is show how we can reuse data. So we're going to add the extra conveyors. Select. So we're going to select everything in this branch of the circuit. Sure you don't select the conveyor's location box. And we'll control or copy and paste it down. Actually, before I do that, I will do that, but just 1 second here. Something we want to do with the cable, this is just for maybe a little extra credit down the road. Hit properties. I'm going to say do calculation on this cable. And since we're putting this 240 volt 4 kilowatt amp motor on here, we're just going to fill in some basic values here. So maximum full load current might be about 17 amps, and inrush factor of 3, we'll say. And that way, we're ready to start doing some calculations. So we'll hit Control, close that out for right now. And where that comes into play is in our design rule check. We now have a cable where we can calculate a voltage drop. All we need to do is assign it a length. And the reason I did that now is because now that characteristic of having the calculation used will carry through when I copy and paste and use this in a macro. So there's copy and there's paste. And we're going to go over to our macros tab, and we'll show that we can do the same thing by just dragging it into a macro and give it a name so you can search for it, but won't bother doing that right now. And then we'll just drag and drop it back into the system. Hit finish, and we now have wire 2 and wire 3. It's copied all the cable characteristics. Those will all show up in calculations now. And drag my location box around all 3 of those. It's kind of interesting though. The attributes are smart too. So if I don't have the box around this motor, it tells me it's in L2. But once I put it in the L2 box, I don't need that attribute, so it disappears. So that's That's kind of nice. All right, assign component. All three contactors are going to belong to K1, single mark. And as a result, it doesn't know what to label these terminals, because if I look over at K1, I'll see that it doesn't have those circuits. They're all showing up in red. So we're going to assign another component here. And it's going to be under type. We need to pick auxiliary. When we do that, we expose our 6-pole auxiliary contactor. My red circuits all turn green. Perfect. Hit OK. Cross references are now all green. And of course, if I go to the power page, terminals are now all labeled. So that part's good. Last step here, we're going to create the sensing logic for the pneumatic cylinders that are going to control where the packages go, I guess. And so we'll first jump into the command palette, just drag this over, and we'll place it towards the bottom of the page. I'm just going to line up the cursor or the crosshair here with that that leftmost wire on the screen. I'm going to drag power wire down to connect, and maybe I use origin destination arrows for the ground, just so I don't have to draw a wire across the screen here. Anyhow, let's add in the sensors. So just kind of zoom into where you can see this big area here in the middle, and we'll say find. Let's do a 3-pole. We're looking for 3-wire. The 3-wire sensing switch. Hit the space bar a couple of times to rotate it around, and we'll just kind of place it a little to the left of center, and then we'll draw the wires for it. Starting off with 1 wire, so we're going to connect up to the output there, then we'll switch it to 2 wires with a 0.25 inch spacing, and just line up the first one with this top wire here, and connect, and see it's picked up the style and connected onto the ground intelligently as well. So, and at this point, what we'd like to do is say the sensor is going to be outside of the cabinet. It's going to be out on a conveyor somewhere, and we're going to use a cable, a 3-conductor cable, to get there. So let's put in some terminals so we can connect to this cable. So for the terminals, I'll just come over here to the left side. I'm making now a new terminal strip, X2. That's fine. And we'll create another one over here. And remember, now the arrow has to point towards the sensor, because the sensor is outside the cabinet. So we're pointing towards the sensor, and we're going to attach this to terminal strip X2. We're not making a new terminal strip. And now we say that. So we have terminals 1, 2, and 3 are all going to this one cable. And you'll see why I'm doing this in a little bit. I'm just going to hide the parent mark attribute, and now I can go in and edit the terminal strip. So we'll put in 3 small terminals, and then we need to assign a cable. So let's make a new cable. Again, we'll pick AWG, and we'll pick control. You may have a couple in your library, but look for the one that's made by SWST. So we'll add that. And it's got 3 cores. You can see, so I want my black to go to my ground, my red to go to my power. That's wire 204. Oops, dissociate. Red to go to wire 204. Dissociate. Oops. Wow, I just messed all those up. Okay, dissociate all of them. Is that one right? They're all wrong. Okay, let's try that again. Associate cable cores. All right, we've got the wire, got the cable in here. So we have black and red. That's ground and power. Pick those 2. Yellow is going to be my output, so that's the one that's going to terminal 3. So we associate that. So red is our power, ground goes to black, and this third one is our output. So that's yellow. Okay, so we're ready for that, and we'll generate the drawing, hit OK. Okay, next step here, we'll create a copy of this because we're just going to have 6 of these sensors going down the page here. We're going to use up all the inputs. So bring the second one down and notice now we have terminals 4, 5, and 6. I just don't like the placement of these symbols right on top of each other. So we'll use the stretch command. Put below to the right, drag up, and you're probably going to select this upper sensor, hold the control key and click it, right click with your mouse to complete the selection, and just drag this off to the side. And then just keep everything nice and neat. Just drag a big box around those texts, create a vertical line, and center the text on the line. You've got a neat looking 2 circuits that are very easy to copy now. So select, hold down the control key while dragging, and then release, and then do it again. Drag, hold down the control key, and release. And finally, these top 2 terminals, numbers 1 and 3, let's go ahead and show the parent terminal strip mark. So we know this is all terminal X2. So if I hadn't hidden that X2 terminal symbol beforehand, we'd see X2 on every one of these and on every other one of these terminals down the left, so it would be kind of messy. Okay, we notice that the conveyors, the only components on the conveyors are the motors. So let's create a location outline right around these. These are all on the conveyors. Change the location. So now all of those components are over here on the conveyors. Moving on. Okay, insert a black box. Not sure what symbol. Just using the first black box symbol here. And all that matters is that it's tall enough to go from to go directly across from the outputs of the other device, of the controller. We'll specify a component type, pneumatic hydraulic. That automatically sets my mark as a Z, and then we can add the component manually. We need 8 circuits. Select all 8, and then change any one of these fields to 1, and they'll all change to 1. Pick the bottom 4, and we're going to say these are all hydraulic pneumatic. Now we're going to pick the top 4 and change these to digital PLC input. Last step here, just to make sure that all the terminals get labeled right. So just to save time, I'm going to select that in-0, type 1, hit the down arrow, hit paste, hit 2, down arrow, paste, hit 3, down arrow, hit paste, hit 4. Do the same thing for the outputs. Aldo 1, down arrow, paste 2, down arrow, paste 3, down arrow, paste 4. So in just really a few seconds, we've created the circuits, and now we're ready to give it a part number, give it a manufacturer, and I need the dimensions, so we'll say it's 140 by 70 by 30. The 140 by 70 millimeters, those are going to be the size of the footprint that goes in our 2D panel layout. So we need that information in there. And then the other things we might do some description. Call it whatever we want. So we'll add that in and say OK. And finally, we just want to add the remaining circuits to this device, and that's going to be in my macros palette. Yikes, there we go. There it is. Cylinder, and we'll drag another one in. Finish. Use the stretch command to grab the wires, or hoses in this case. And then we'll create our 4 wires. They're spaced a ½ inch apart. I'll go to my 4 outputs. Okay. All we do now, update the black box and assign the circuits of the black box. So here we actually will go into symbol properties here at the top of the list. And you see my circuits from the CAD symbol and my circuits from the manufacturer's part that are assigned to it. I just need to match them up. I can see 1, 2, 3, 4 going down the left side. Those are my inputs. 5, 6, 7, 8. Those are my outputs, so easy. A little repetitive dragging and dropping here. Oops. Okay, all done, but now everything's labeled nicely. Okay, so this much of the project is done now. The design is done. We haven't updated our terminal strip drawings, as you can see. So let's do that. Select the two terminal strip drawings and say update. And finally, you can see in this terminal strip number 2, notice how terminals 1 and 2 are large. They have 2 wires going in each one. So what we have is the power wire coming in, then we have this jumper going out to connect from terminal 1 to terminal 4. Then we connect from terminal 4 to terminal 7. So it's kind of messy. And we do the same thing with the ground. So you see a lot of GND1 here. So what we're going to do is we're going to tile those together with a what do we call it? With a bridge. So everywhere where we see a 204 or a pair of 204s more directly, we're going to tie this together. So you can see I have all six of those selected, create bridges, and we'll do the same thing with the ground, which is just going to be terminals directly below the ones that have bridges now. Create bridges. I'm going to regenerate the drawing. And as you can see, because it made everything more compact, I was able to move the automatic page breakdown. But we're splitting a cable with 2 cores on one page, 1 on another. Don't like that, so let's put the break below wire 7 here at terminal 12. That way I can get 4 full cables on one page and 2 on the other. And we'll update that. Hit OK and close. And there's our drawing. Looks a lot neater. And we're going to do the same thing over here with this page. And that is tie all these grounds together. Actually, before I do that, I just want to point out, look here on the drawing style, because I added bridges to tie the power and ground together, the wire style appearance changed to show me that those are tied together with a bridge. And the same thing will happen over here on the power page. Notice we've got this green wire style going to all the every 4th terminal, but we'll fix that by just tying our 3 grounds together, updating our drawing. And let's go back to the power page. So this looks a little neater. And sure enough, you can see that bridge wire style right there connecting the 2nd and 3rd motor ground terminals together. So at this point, the design is complete, so we're ready to do the panel layout. So let's do that. Process 2D cabinet layout. Just want the main electrical enclosure. This will give us the cabinet in the door. So let's come over here. And we need to add a cabinet. So I'll just do a reference search for 1055. It's a relatively compact cabinet. I'm going to grab its door, and I'm going to grab the mounting plate. Add those both to the system. And already I don't like the scale on this. Let's add the mounting plate in just to show it's too small. We can make this a lot bigger. So let's go over the document tab with the main electrical enclosure selected. My properties tab shows my scale. Change the scale to 1 to 5. Hit OK. And go back to our cabinet layout tab. And I'll just reposition. That's good. Okay. And at this point, I'll just start laying out the cabinet the way I want to see it. So cabinet layout. Let me go ahead. My cylinders are in the cabinet. We'll fix that real quick. So go back to the control page. Just something I forgot to do. cylinders are no longer in the system. And let's insert the fuse. So we're going to have our power wires coming in from the top, and then we're going to add our power supply and our circuit breakers. We go right, and we're going to horizontally with a spacing of 3/4 of an inch. And I'll just drag this guy a little off to the side though. I want the power supply to be at the edge. And the idea is since I'm kind of limited for space vertically, I'm gonna have, rather than putting the circuit breakers right here below the power, where I'd have power coming here and then coming out into circuit breakers, I'm gonna have to reroute my cables up like that. So I'll put a duct in there and I'll fix all that later. But what I'm just do is set up the basic layout and then move from there. So line our controller up, and then we'll do our contactor. And remember, this is actually 2 parts. And so place the contactor first, and then to its right, we're going to place the auxiliary. And we don't want any spacing in there, so we'll just delete the spacing. And this will be more or less below my circuit breakers. And then we need to add our terminal strips and our pneumatic device. So let's put in our terminal strip number 2. That's the one for our controller. And so we'll place it starting right below the controller. Good. And we'll place our pneumatic device. See, it's already come up with the right size footprint. And finally, we'll insert okay. Okay, and insert terminal strip. There we go. Line it up where it needs to go. Okay, and now we're just ready to lay out some ducts. So we're going to place one duct that's going to go horizontally here. We're going to use a couple of those. Actually, we'll put one up top, one down here, and that's plenty. And then we'll do one more. So we'll say add a duct. Pick the same part, but we're going to do a rotation and specify the length. So that's good. All right, next we'll add some rails. Just picking this 34486 part and horizontal orientation. Okay, and then we'll, rather than copying, let's see, we'll just copy and paste the rail to get this short segment and paste another one down here. And now I'll just update the rail lengths. So picking this rail length, we'll update it to that size, and we'll update this one to that size. And now this is the size rail I want to use below, so just copy and paste. That's done. And of course, now you see since the rails were created last, they're on top of everything. So we've got an ordering command here where I can say move below entity. And so now I'm just going to make a selection. Control select, whoops, not the circuit breaker, but all the different rail components that you just added. Right click to complete the selection, and then just click on this fuse up here, and then it's going to move the rail below. So all the ordering is done, and right now we just want to make sure we have everything in the cabinet that needs to be there. All that's remaining are my 2 switches. So we'll come over here to this page, insert the switches, and maybe we'll go vertically with a 3-inch separation. There we go. So there you go. So now we've got all the documents created for this. The next step would be really, I mean, at this point we can go back and create the PDF or whatever. There is something new in Electrical 2017 where if I try to export right now, it'll tell me that I need to update some drawings. So if I had all my drawings closed, it would just update them automatically. But actually, I haven't even added reports yet, so let's add the reports. Okay, schematic project reports. The ones we want to draw are going to be those first four: list of wires, bill of materials, drawing list, and cables. You can see those getting added right here. Don't really like the order that things are in right now, so what I want to do is put my cables right here at the very end. I want my cabinet layout before my terminal strip drawings, and I want my drawing list right at the beginning there. And here we'll just go over to the process tab and say renumber documents. Whoops. So we've recalculated all the numbers. Just to be clear, there's a checkbox. I think you need to make sure that that one's the option checked. Recalculate order numbers. Okay, so now you get everything in order based on the order they're on this list. If you notice the drawings list is not correct, it doesn't show all the pages. Okay, now it's updated for everything, and that's a little issue. This has to do with the order that we create things in. So schedule, if I look at this, my list of drawings is way up here at the top. It's creating a drawings list, then it's building a bill of materials, so it doesn't know those pages exist yet when it creates the drawing list. Make sure that's the last item we update. Okay, so that's just for the next run through, it'll update everything correctly. But because I renumbered everything, now of course my device marks are wrong. This should not be a 02Q1 because we're actually on page 3. It should be an 03Q1. So let's recalculate marks. So again, we started renumber documents. Now we're renumbering marks. Just looking right to left in this list. So now it's 03Q1, 03PS1, and so forth. And renumber wires. Let's go to the control page to appreciate the change here a little better. Let's numbered our wires. Maybe I want to see my wire numbers here, but not above the cables. Oh, yikes, excuse me. There we go. So now I've got the wires labeled the way we want them. And yeah, so at this point we'll renumber all the wires just to make sure that we don't have anything that's wrong. Okay, so we've numbered our new wires, we've renumbered everything. Yeah, all these are changed to 4s now, 402, 404. And the last step, now that everything's correct in terms of marks and wire numbers, we'll just go ahead and update all of our reports again. So say draw reports here, update selected reports. So there's the order, drawings list at the very end. Okay, so we're all ready with the project. Now we can export to a PDF and we're ready to go. The kind of little extra credit thing we'd shown with the wire with the voltage drop. Here I've got 3 cables. I don't have any links. If I had electrical 3D, I'd send it out to 3D, I'd route it, I'd have the links, and then I'd get these voltage drop, all the voltage drop data. And this system is set to give you a warning if it's more than 8%. But let's just set some lengths arbitrarily on these. So maybe it turns out that wire number 1 is going to be about 57 meters. Wire 2 is going to be, oh, I don't know, maybe 97 meters, and wire 3 is going to be 178 meters. There we go. So when I calculate now, are you kidding me? see what's going on here. Oh, well, how about that? For some reason, we don't want to update. Okay, maybe we're not going to get the extra credit. Let's see. Oh, there we go. So apparently we can't just add it here from these fields. Maybe that's a bug. Maybe that's, well, I'll call it a bug. But anyhow, the see the warning has come up here because because this really long cable, we've lost 25 volts. That's more than 10%. The warning comes in at 8. Even at 5.6%, that's pretty close. I mean, I don't know if I want to have that kind of drop happening. So especially if I think I might upgrade to a higher power motor in the future or something like that, might as well cable it up the way it needs to be. So what I can do with this is go into my cables list. This first one here, this third wire number 3 is really the one we're concerned about. So let's do a replace, and you'll see this is really quick. We just switch over to power. We pick a 10 gauge instead of the 14 gauge, so it should have a lower drop. And sure enough, its drop goes down to 4.3% from over 10%, and so we've got delivering more power to the motor that way. Anyways, that's just a quick way to show how we can handle all of this. And if we look at our cable group, okay, so we've got our 3 cables here. Let's just update this report now because I did change that cable. So now you can see I've got one of these 10 gauge cables. I need 7,000 inches of that, and I need 6,000 inches total of the other 2 cables. And that's basically it. So that takes you to the demonstration again. Yeah, export the PDF file, show all that stuff. But this is just a quick overview of how you get through this demo and some of the things to look out for. All right.